welcome to channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start discussing about chemistry here. That is your class uh, this is your part 2, which is your class, your 12th class. We had done your class 11 in the last classes, where we had started with the unit that is the haloalkanes and haloarenes, and that is your important unit as well. And this is your 10th unit, which we continue here. So unit 10, haloalkanes and haloarenes. This is the 12th that is the class of this particular subject of chemistry. That is what we continue here. So before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than unit 10, we had done your unit 1, which is your in the part 1, that is the solid state. Unit 2, which is solution. Unit 3 is electrochemistry. Unit 4 is chemical kinetics. Unit 5 is surface chemistry. Unit 6 is your general principle and processes of isolations of element. Unit 7 is the P block element. Unit 8 is your D and F block and elements, and unit 9 is your coordination compound. And this is unit 10, which is of part 2, which is haloalkanes and haloarenes, that we continue, where we had completed the classification, nomenclature, nature of carbon halogen bonds, methods of preparation, physical property, chemical reaction, polyhalogen and compound. That what we have to cover up. So let's start it with the same, where we had done the numerical as well on the basis of the each and every topic in the last classes which we had completed. Started here. The last topic that we had started is your with including the tables as well in the detail. We had done your the chemical reactions here, where we had done your reactions of halogens as well, with the detail, and after that we completed with the substitution, nucleophilic, unimolecular reaction, and lastly we had done your stereochemical aspects of the nucleophilic substitution reaction, which comes under the retention, inversion, racemizations and optical activity. So now today we start discussing about the second part of it, which is stereochemical aspects of that. We continue stereochemical aspects of nucleophilic substitution reaction that will be discussing the plane polarized light and an optical activity that we had done. The second one for that we have is about molecular asymmetry, chirality and antinomally. Just I write it on the first part, so you will get to know about it. The first is what we had discussed as plane polarized light and optical activity. So that I just tell you once in a short way that we had done and discussed in the last classes in the detail about it. You can go for the same. So here for plane polarized light and the optical activity, where the certain compound rotate the plane polarized light that is produced by the passing the ordinary light through the Nicol prism, and when it pass through the solution, such compounds are called optically active and compound, and that the angle by which the plane polarized light rotate to measure by the instrument are called polarimeter, and it compound rotate the plane polarized light to the right and it compounds rotate the plane polarized light to the right and clockwise direction. It is called dextrorotatory, which is Greek for right here, rotating, and that the deform and the indicated by the placing a positive sign before the degree of the rotation if the light is rotated then towards left anti-clockwise direction. That is, that compound is said to be the that is the leave rotatory, and the L form of a negative sign that to be placed before and are called optical isomers, and the phenomena is termed as an optical isomerism here. Now we discussed another one, which is the molecular asymmetry, chirality, and enantiomers. Second part is molecular asymmetry, chirality, and enantiomers. So this is the second one here, where the observations of Louis Pasteur in 1848 and a crystal of certain compound that exists in the form of a mirror image that led to the foundations of modern stereochemistry. He demonstrated that the aqueous solution of both the types of crystal that showed optical rotation and equal in magnitude for solution of equal concentration but opposite in direction. He believed that the difference in the optical activity was associated with the three dimensions arrangement of atom, that is your the configuration that we talk about in the detail here. With the same in the configuration, the two types of crystals, and the Dutch scientist, which is J. Van Zhoff, that is the French scientist C. Lebel, in the same year 1974, independently argued that the spatial arrangement of the four groups, that is valencies around the central carbon, is a tetrahedral, and if all the substitutes attached to the carbon are different, such a carbon is called asymmetric carbon. So just I write it down for you all. Jacobs, Hendricks, and the Wenthoff 1852 to 1911, that received the first Nobel Prize in the chemistry of 1901 for his work on solutions. So let's go for it. If all the substituents attached to that carbon are different, such a carbon is called asymmetric carbon or stereocenter. So they are the resulting molecule that would lack symmetry and is referred to as asymmetric molecules. The asymmetry of the molecule is responsible for the optical activity in such organic compound. So where that the symmetry and the asymmetry that are also observed in many day-to-day objects, a sphere, cube, cone, that are identical to their mirror images, and that can be superimposed. However, many objects are non superimposable on their mirror images. For example, your left and right hand are similar, but if you put your hand on your right hand, they do not coincide. and that the object which are non-superimposable on their mirror image, that like a pair of hands that are said to be a chiral, and this property is known as chirality, while the object which are superimposable on their mirror images that are called achiral. And that is been asked in the difference between, or a simple the term has been asked, so I just write it on for you also, that you will be able to write it on if they had been asked here. So let's go for it. Objects the objects which are non superimposable on their mirror image like a pair of hands. Are said to be chiral. And this property is known as chirality. Now, while the objects which are superimposable on their mirror image are called achiral. Okay, this is the here the chirality, chiral and achiral has been formed here. So where the above test of molecular chirality that can be applied to organic molecules by constructing the models and its mirror image, or by drawing three-dimensional structures and attempting to superimpose them in our minds. And there are other aids however that can be assist us in recognizing the chiral molecules. One such aid in the presence of a single asymmetric carbon atom, let the consider to the two simple molecule propan 2-ol and butan 2-ol and their mirror images. So let's go further and find it out as well. Well, some common examples of the chiral and achiral object is, that is the hands here in the mirror, and the footprints, that is the chiral object, which is, non-superimposable mirror images. अगर आप एक हाथ को अपने मिरर के इस साइड रखते हो और ऊपर उधर से विजिबल होगा, so ये they are the not imposable, that are not superimposable, they are just looking like a different one. So that is your known as your world chiral object. And if you're taking a similar glass or a ball, so the non-chiral object, that superimposable mirror images, so they are superimposable, that is look like as same as that you had taken those object in the mirror as well, that is the similar. So this is known as your achiral here, non-chiral object. So for that, if you're taking the butane to all in the mirror, or propane to all, so it will be C obtained by rotating B by 180 degree, and C is superimposable on its mirror image A here. So on the same way, as you can see very clearly, the propan to all does not contain asymmetric carbon, as all of the four groups that you're attached to the tetrahedral carbon that are not different, that is, it is called a chiral molecule. That is on the same way we go further, then we'll discuss about it in the detail here. So here for another one, if the butane two has a four different groups that are attached to the tetrahedral carbon, and expected is a chiral, where the some examples of the chiral molecules such as 2-chlorobutane, 2,3 dihydroxyl propanol, and bromochloroidomethane, as well as 2 bromo propane acid as well. The stereo isomers that related to each other, as that is the superimposable mirror images, are all called enantiomers. So let's go for the same. The stereoisomers related to each other as non superimposable mirror image are called enantiomers. Okay, so that you will be able to write it on the definitions of those. So here the enantiomers that possess the identical physical properties, namely the method point, melting point and boiling point, refractive indexes, etc., and their only difference with respect to the rotation of the plane polarized light. If one of the enantiomers are dextro-rotatory, the other will be levo-rotatory. So, however, the sign of the optical rotation is not necessarily related to the absolute configuration of the molecule. So, I just write it on for the enantiomers. Enantiomers possess identical physical properties, namely melting point, boiling point, refractive index, etc. A mixture containing the two enantiomers is equals to the proportion as have zero optical rotation, as the rotation due to the one isomers will be cancelled by the rotation due to the another isomers. Such mixtures are known as racemic mixtures or racemic modification. So that is also been important one. So that, and the process of conversion of enantiomers into a racemous mixtures is known as racemization. A mixture containing two enantiomers in equal proportion and have zero optical rotation as the rotation due to one isomers will cancelled by the rotation due to the other isomers such a mixture is known as racemic mixture or racemic modification. Racemic mixtures and racemic modification. This is how it is. And that the process of conversion of enantiomers into a resin mixture is known as racemization. So now we go for the questions here that has been the recording this only, and so which is about the molecular asymmetry, chirality, and the enantiomers as well. Let's go for the same. But before starting with the same, it's a huge request to all the viewers to please go ahead with like, share, and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So for that same, here we go. The question is, identify the chiral and the achiral molecule in each of the following pair of compound wedge and dash representation according to the class 11th. So let's go for it. The first one we have this is the question number 8 of this unit. So identify chiral and achiral molecules in each of the following pair of compounds wedge and dash representation according to 11th class. So let's go for it. The first we have hydrogen CH3 Br OH CH3 H Br Br पहला इसका है आपका एंड इनमें से आपको बताना है आइडेंटिफाई द chiral and achiral molecule in each of the following and so another we have the second one here OH H CH3 CH3 and there is OH H CH3 and this is CH3. The third is so CH3 CH CH2 CH3. This is Br. CH3 CH2 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 Br. So this is the first part, this is the second part. Here for the same first one, second, first and then second. So for that we have another the description that is related to it and the solution for the same. It will be for the first one it will be CH3 hydrogen OH Br. This is for hydrogen OH CH3. For the third one it is CH3 CH CH2 CH3 Br. So you go for it, you will figure it out. So here we're gonna end up with, and thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and with you can also enjoy the video as well. Thank you.